Hello everyone, a very good evening to each and everyone out there, and I welcome you all to this amazing platform of PW English class 9th and 10th and to your Phoenix batch. So in this particular video, we are going to do the one shot of one of the easiest and the most smallest chapter from your book, that is Euclid's Geometry. So we are going to start with the Euclids, and of course we are going to do everything, every axiom and every postulate. So let's see that what we are going to discuss in this class. So we are going to start with the introduction. Then we are going to learn about the axioms and the postulates along with Euclid's axioms, Euclid's 5 postulates, statements, what are theorems and the corollaries, some terms related to geometry, incidents, then we collinear points, intersecting lines, concurrent lines, planes, theorems, questions and everything. So basically when we talk about geometry, so there are certain things that are very basic when it comes to geometry, like line segment, ray, points, right? And there are certain things that are like said as common sense, like, oh, this is very common, we know this happens. But again, this has to be taught by someone, this has to be invented or discovered by someone. So let's start that what all are Euclid's axioms, what are postulates, let's give a throw. So basically, axioms and postulates, what are that? So self-evident true statements used throughout mathematics and not specifically linked to geometry are called axioms. Now, what are axioms? Self-proven statements. Basically, statements which do not need any proof. In English, we say them as fact. Sun rises from the east, sets in the west. It's a fact. We do not need any justification for it. We do not need any proof for it. It is a fact. It is a self-proven statement, right? So, the self-proven statement, self-evident statement, right, which does not require any evidence to prove itself are known as axioms. And axioms are not only limited to your geometry part. It can be used in all the other arithmetic parts of the maths, advanced parts of the maths, trigo, any other chapter, right? So those are axioms, while those specific to geometry are known as postulates. So both of them are self-evident, non-proven statement, basically the statements which do not require any proof. But the part of them which is only used in geometry is called postulates, and axioms can be used in any other fields in mathematics apart from geometry as well. Both of them means the same, right? So nowadays we do not distinguish between axioms and postulates, but again, axioms is not only limited to geometry, but postulates are limited to geometry only. The next thing that we have are Euclid's first axiom. Let's see. So the first axiom is things which are equal to the same thing are equal to one another. Again, very easy. If A is equals to B and B is equivalent to C, so from both of them we can say that A is equivalent to C. Things which are equal to the same thing are equal to one another, and this is the very first and the very basic axiom that Euclid has said. The next is if equals are added to equal, the wholes are equal. For example, if AB, let's say if A is equals to B, both of them are equal, right? A is equals to B. If I add C both sides, let's say I have added C to both the sides of the equation, now it becomes A plus C and this becomes B plus C. So simply, if equals are added to the already thing that are equal, the result is also equal. Let's take one more example. We know that 10 is equivalent to 10, right? 10 is equivalent to 10. If we add 3 to both sides, what do? If we add 3 to both the sides, equals, added equals, and the result will also be equal. This is what Euclid's second axiom means. Now the third axiom is if equals are subtracted from equals, the results are also equal. Again, we know that 7 is equivalent to 7. If I subtract 2 from both the sides, 7 is equals to 7. I have subtracted the same thing from both the side, minus 2. Now this 5 will be equals to 5. So we can say if A is equals to B, so if I subtract from both the sides, so again the result will also be equal to each other. The fourth thing says things which coincide with one another are equal to one another. Coincide means overlap. For example, I have drawn a circle, let's say I have drawn a circle like this, and I have drawn one more circle like this, right? And this circle coincides almost to the other circle. There are two circles and I have drawn two circles and both of them have the same radii. Things which coincide with one another. Now this circle coincides, like totally overlap the other circle. So both of them have the same radii. Both of them are equal to each other. The next we have is the whole is greater than the part. Of course, if we have a pizza, let's say we have a pizza and it is divided into 4 parts, and if you take one slice of pizza, this is the whole pizza. If you take one slice of this pizza, so this whole pizza will always be greater than the slice of it. So what do we say? That whole, right, is always greater than the part of it. Clear? Next, things which are double of the same thing are equal to one another. For example, if I draw a line of 2 centimeter. If I draw a line of 2 centimeter. Now what is the double? If I draw a double of it, let's say 4 centimeter, and this one is also 4 centimeter. Right? So what I can say that this line is also double of this and this line is also double of this. So what we can say that this line is equivalent to this line. Again, if I say with variables, if I say that A is equals to 2B, right? Or I can say that twice of A is equals to B and twice of A is also equals to C. 2A is equals to B, 2A is also equals to C. So from here we can say that B is equals to C. Getting it? So things which are double of the same thing are equal to each other. Next, things which are half of the same thing are equal to one another, same point, right? Earlier it was double, now in this case it is half of it. Now let's move forward. Now let's read some illustrations. Now what is the first illustration? If the area of a triangle equals to the area of rectangle and the area of rectangle equals to the area of square, then the area of the triangle also equals to the area of square. First axiom. Things which are equal to each other are equal to one another. Things which are equal to the same thing are equal to one another. So if we have the area of triangle which is equal to the area of rectangle and the area of rectangle is equivalent to the area of square, so area of triangle will also be equivalent to the area of square. Next, magnitudes of the same kind can be compared or added or subtracted, but magnitudes of different kinds cannot be compared. Units. I cannot compare length with weight, right? I cannot compare height with breadth. That's the comparison that we are talking about. So the units has to be same. Next, what do we have is everything equals itself. Of course, this pen is equivalent to itself. I am equivalent to myself. This remote is equivalent to itself. So everything is equivalent to itself. That's for sure. Next we have is if A is greater than B, then there exists a quantity C such that A is equals to B plus C. For example, we know that 10 is greater than 5 or 7. Right? We know that 10 is greater than 7. So there always exists something to be added in 7 so that this quantity becomes equal. This is what this illustration is talking about. The next is a straight line may be drawn from any one point to any other point. Euclids assume that there is a unique line joining two distinct points. So in between 2 points, you can only draw one and one line passing through those 2 points. The next we have is a terminated line can be produced indefinitely. So if I have drawn, in construction it happens, right? For example, you had to draw 7 centimeter and by mistake you have drawn 5 centimeter. So what you will do? You will keep the scale again and extend this to 2 centimeter so that this line becomes 7 centimeter, right? So if a line is terminated, again you can do what? Extend it from both the ends up to your desirable length. Next, postulate 3. A circle can be drawn with any center and any radius. Of course, we can draw a circle with any center and with any radius. Next, all right angles are equal to one another. So, all right angles are what? Equivalent to one another if they have the same base and the same height, of course. Next, Playfair's axiom, important one. Let's understand this. If a straight line falling on two straight lines make the interior angle on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, they intersect, they meet on the line in which the sum of the angles is less than two right angles. That means less than 90 degree, 2 of 90 degree. Right? Now next, let's learn about statements. Now what are statements? Right? A sentence which can be judged to be true or false is called a statement. So whichever question you get for true and false, it's a statement. Have you listened to the question, heard the question, read the question properly? Given below a few statements, say true and false for them. So what are statements? Statements are something that you can judge to be true and to be false. For example, the sum of the angles of a triangle is 180 is a true statement. The sum of the angles of a quadrilateral is 180 is a false statement. But x plus 10 is greater than 15 is a sentence but not a statement. I hope this part is clear with everyone how to judge whether it's a sentence or a statement. Let's move forward. Now theorem. A statement that requires proof is called a theorem. You have learned a lot of theorems in your class 9th. You will learn a lot of theorems in your class 10th. So what are theorems basically? What do we do with theorems? What do we actually do with theorems? What shall we prove them? Right? So whenever a theorem is given to us, whenever a theorem is there with us, we give a proof for it. Right? Establishing the truth of the theorem is known as proving the theorem. To tell whether a theorem is correct, true or not, we prove it. The sum of all the angles around a point is 360. Angles of a triangle is 180 degree. We have done a proof for all of them. Corollary. A statement whose truth can easily be deduced from the theorem is called its corollary. The reverse of it. Next. A point is an exact location. Of course, whenever you want to reach somewhere, you look at the location. What is the location? The coordinates, the point. If I draw a particular point, so this is some exact location, right? So this is, a point is an exact location. Line segment, of course, we know, right, which have a fixed length. The straight path between 2 points A and B is called the line segment and it simply has a fixed length. Ray. We know what are rays, sun rays. It starts from a fixed point but does not have an ending. So such a thing is known as ray. A ray has no definite length. A ray cannot be drawn. It simply be represented on a plane or paper. The next we have is line. So we know that line has arrows on both the ends. So that means that it can be extended both the ways. It does not have any ending. A line has no endpoints. It does not have a definite length. And also a line cannot be drawn. It simply be presented on a plane of paper because it is never ending. If I go till here, what after this? The board is finished. Now where to go, right? So it can only be depicted as arrows in the particular things. Next, half lines. Let A, B and C be 3 points on a given line L such that A lies between B and C and we delete the point A. Then each of the two remaining parts namely will be the half lines, right? So if A is a part, that line or line we can also call them as ray kind of because it has one point at a stiff point and the other one goes beyond the part. I hope that this thing is clear with everyone, right? Okay. Now let's move forward and let's see what we have. So a line contains infinitely many points. So if we see at this line, so this is one point and it is infinitely many points. So line is a collection of infinitely many points. Through a given point, infinitely many lines can be drawn. If this point is given to you, you can draw as many lines as you want through this one given point. Next, one and only one line can be drawn to pass through two given points. If we have two given points, only one line can be drawn through it. Three or more than 3 points are said to be collinear. What is collinear? If they lie on a same straight line. If there is a line which contains all of them, if there is a line in which all of them are here, then it is called as simply your, what it is known as, collinear points, if they lie on a same straight line. Intersecting line which crosses each other at one single point is intersecting lines. Concurrent lines, if many lines passes through one common point, right? Three or more lines intersecting at the same points are said to be concurrent lines. The next we have is a plane. A plane is a surface such that every point of the line joining the 2 point lies on it, right? The wall, the sheet of paper, everything is a plane. Next theorem, the first theorem, prove that two distinct lines cannot have more than 1 point in common, right? If there are two distinct lines, so we cannot have more than one single point in common. Now let's read about some few questions. The very first question that we have, bacha, over here is, what do we have to do in this? So, if A, B and C are 3 points on line and B lies between A and C, prove that AB plus BC is equivalent to AC. Right? So, what do we have to prove that AB plus BC is equals to AC? First of all, B coincide. First of all, what we can say that A, B and C are collinear points. Right? What are A, B and C? A, B and C are collinear points. So, we can say that AC is equals to, right? What do we have to prove? That AB plus BC is equals to AC. So, first of all, from Euclid's axiom 4, what we can directly say, by using axiom 4, we can directly write the statement that AB plus BC is equivalent to AC. Next question, prove that an equilateral triangle can be constructed on any given line segment. How to do this? First of all, let's say we make a line segment. AB, and let's say that this AB is equivalent to X. Any measurement? So, let's take this AB equivalent to X. Now, what do we need? We need a compass, right? So, once we get the compass, what do? We open the compass up to this whatever length is given to you, and what do? We draw a circle like this, and what do? We draw a circle, right? The same thing we do when we keep the same point at B and then we draw the circle again. So, what we have done, first of all, we kept the point at A, opened it up till B and draw the circle with the radius X. Similarly, by keeping the point at B, again we draw it in the same radius. Now, what do? From this point of intersection, we join the point A. From this, we join the point B, and this becomes the triangle ABC. So, from any length that is given to us, we can very clearly construct an equilateral triangle, and we can say that if two circles have the same radii, they are equal to each other according to the axiom. Now, the next question, there are true and false. So, what does this question say? The question says, only one line can pass through a single point. So, if we have a single point, infinitely many lines can be drawn through it. So, this statement is a false statement. So, this statement is what? This statement is a false statement. The next we have is, there are infinite number of lines which passes through two distinct points. So, this statement is also a false statement, because if we have 2 points, bacha, only one line can pass through it. Only one line can pass through these points. The third is, a terminated line can be produced indefinitely on both the sides. So, if we have a terminated line, we can extend it to both the sides. So, this becomes a true statement. The next, if two circles are equal, then their radii are equal. So if two circles are equal to each other, then of course we can say that their radii are also equal. So it becomes a true statement. Right? The next we have is, if AB is equals to PQ and PQ is equals to XY, so AB is also equals to XY. This again becomes a true statement, bacha. And why we can say that this is true? By Euclid's first axioms. If one thing is equal to the other, another thing is equal to the third thing, so first and third thing are equal to each other. So I hope that how to do the questions, how to tackle the questions, you are able to do it. Let's move forward to the next question. Okay. Now the question says, if a point C lies between 2 points A and B such that AC is equals to BC, then prove that AC is equals to half of AB. So first of all, we draw the line AB and there is a point in the center, that is C. So first of all, we can say that AC is equals to, we can say that AB is equivalent to bacha AC plus BC. What we can say? That this AB line is equals to AC plus BC. Now the next thing that we have is AC is equals to BC. So in the place of BC, what we can write? AC plus AC. Now AB is equivalent to twice of AC. If we shift this 2 over here, so half of AB is equivalent to AC. So what we can say, that half of AB is absolutely equivalent to your AC. I hope that this is clear with everyone. The next question is, if a point C lies between 2 points A and B such that AC is equals to BC, if point C is called a midpoint of AB, then prove that every line segment has one and only one midpoint. So how we can do it, bacha? How to do this question? So first of all, what we can say, that AB is equals to AC plus BC. Again, because C is the midpoint of AB, right? And let's say there is one more midpoint. Okay. Okay. So we have AB and we are given C. So let's take no. There is one more midpoint. Let's say, no, I am not agreeing with it. Let's say D is one more midpoint that is present for AB. So we can say that BD, right? So what we can say, that AC. Okay. So first of all, what is AC over here? If we write down AC, AC is AB, right? So we have AC is equals to, this point is C. So AC and that point that we have is B. So what we can say from here is, let's say this is A, let's say this is B, not D. Let's say this one point is B. Alright, and this point is D. Now what we can say about it is, AC is equals to AB plus BC. AC is equivalent to AB plus BC. We can also say that BD is equivalent to BC plus CD. So this is what we have gotten, right? BD is equals to BC plus CD. Now it is also given that AC is equals to BD, right? It is also given that AC is equivalent to BD. So both of them are equal if AC is equals to BD, right? So what we can say, that AB plus BC is equals to BC plus CD. So what do we have? AB is equivalent to CD. What do we have? That AB is equivalent to CD, right? So if AB is equivalent to CD, so what we can simply say, that only C is the midpoint that we were crying for. Next question we have, in the figure AC is equals to BD, prove that AB is equals to CD. Now, we know that AC is equals to BD, bacha. Very simple. AC is equivalent to BD, right? Now, if we subtract BC from both sides, so by Euclid's axiom, we can say, if equals are subtracted from equals, the result is also equal. So, AC minus BC is AB and BD minus BC is CD, and this is what? needed to be proved. So I hope that this is a very small chapter, bacha. It's a very quick to go chapter. And I hope that all the questions that we have done are clear with you people. If you have any doubt, feel free to comment down. So till then, take care. Have a great time ahead. I'll see you in another one shot of another chapter. So bye-bye. Thank you so much.